All right, welcome. Today we are diving deep, like really deep, inside your computer's brain. We're going to meet these tiny unsung heroes that make everything happen in the blink of an eye. Yep, we're talking about CPU registers. I mean, have you ever really stopped to think about it? You click your mouse and poof, something happens instantly. You hit a key, letters pop up on the screen. How in the world does it do that so fast? Well, the secret isn't just about brute force or raw power. It's actually all about incredible, mind-bending efficiency. And not efficiency, it comes from this tiny special workspace tucked right into the heart of the action, inside the central processing unit, the CPU. This little spot is the real key to unlocking the kind of speed we just completely take for granted every single day. Okay, so let's really get into it. To wrap your head around registers, I want you to picture something. Imagine the CPU is a master craftsperson, like a watchmaker or a skilled woodworker. Well, every great craftsperson needs a workbench, right? That's exactly what a register is for the CPU. So here's the more textbook definition. But pay attention to the keywords here: small, high speed, and inside the CPU. See, unlike your computer's main memory, the RAM, or even its cache, registers are physically part of the processor chip. They are literally the most immediate, right at your fingertips storage the CPU can possibly have. And this comparison just nails the difference. The register is the workbench. Everything the craftsperson needs is right there, within arm's reach, no delay. But RAM and cache? Think of those as the shelves and storage closets across the workshop. Yeah, they're nearby, but the craftsperson still has to stop what they're doing, walk over, and grab what they need. Those few extra steps are nanoseconds in computer time, and believe me, they add up ridiculously fast. All right, so we know where this workbench is. Now the question is, what's actually happening on it? What's on the CPU's to-do list? I mean, what kind of work is our little CPU craftsperson doing that's so important it needs this instant, no-delay access? Well, it turns out to be a very specific and super important list of tasks. And what's so cool about this is just how fundamental these jobs are. Registers hold the numbers you're about to add together. We call those operands. Then they store the result right after the math is done. They keep track of where to find the next piece of data in memory, and they hold the actual instruction for the current job. They are quite literally the center of the entire operation. But it gets even cooler and more organized than that. This workbench isn't just one big cluttered table. No way. It's a highly specialized area with a whole crew of different registers, and each one has its own very specific job to do. Yeah, think of it like a Formula One pit crew, a team of total experts all working in perfect sync. Each member knows their role inside and out, which lets the whole thing run without a single wasted microsecond. So let's meet a few of the key players on this team. First up, we've got the program counter, or PC for short. Its official job title? It's in charge of storing the memory address of the very next instruction that the CPU needs to execute. So going back to our analogy, the program counter is the team's navigator. It's got the map and it's always pointing ahead, saying, all right, that's done. The next step in the plan is right over here. It makes sure the CPU never loses its place and always knows what's coming down the pipe. Okay, next on the team is the instruction register, or IR. Now, while the PC is always looking one step ahead, the IR is all about the here and now. It holds the current instruction, the one that's being decoded and executed at this very moment. So if the PC is our navigator, then the IR is holding the current blueprint. It's like the page of instructions laid out right on the workbench that our craftsperson is looking at right now. It's the part that says, add these two numbers, or move this data from here to there. Okay, but wait, all this data has to get to the workbench and then leave it, right? Well, that's where the memory buffer register, the MBR, comes in. It's basically a temporary holding area for any data that's being transferred from the main workshop, RAM, or is on its way back out. And the analogy here is just perfect. The MBR is the workbench's loading dock. All the raw materials coming in from the big workshop get dropped off here first, and all the finished pieces get placed here before they're shipped back out. It's that critical transfer zone. Last but not least, how does the CPU know if a task actually worked out? Like, did the math go okay? That's the job of the status register, sometimes called the flag register. It's a bit different because it doesn't hold data like numbers. Instead, it holds little signals or flags that tell you the result of an operation. You can think of this one as the team's quality control inspector. It's watching the work being done, and it raises a little flag if, for example, a calculation ended up being 0, or maybe if a number got way too big to fit. That's called an overflow. This kind of feedback is absolutely crucial for a program to decide what to do next. So let's just recap that crew real quick. This table lays it out perfectly. You've got the navigator pointing the way, the blueprint for the current job, the loading dock for moving stuff in and out, and the quality control inspector checking the work. Altogether, this amazing little team makes sure every single instruction happens flawlessly and super fast. So why did we just spend all this time talking about these microscopic little components? Well, because when you understand registers, you understand the fundamental secret to why modern computers are so fast. They really are the unsung heroes of the whole operation. So if you're going to remember anything from all this, here are the big takeaways. Registers are the CPU's personal workbench, ultra-fast and right there. Their speed is what prevents everything from grinding to a halt. You've got this whole team of specialists working together in perfect harmony. And let's be real, without them, the phone or computer you're watching this on would be, well, impossibly slow. You know, this quote just says it all perfectly. A CPU's real power isn't just about how fast it can think. It's about this incredibly elegant system it has for getting exactly what it needs right when it needs it. And that, my friends, is the magic of CPU registers. And that just leaves us with one final thought to chew on. As we keep pushing the limits of computing with AI, quantum stuff, and who knows what else, the demands on that CPU are only going to get more intense. So what do you think the workbench of the future is going to look like? What kind of new specialists will join the team? It's pretty cool to think about. Anyway, thanks for joining me on this deep dive.